Have you ever wondered just how far China's power could stretch? The Chinese government has become a world power economically and even in science because of one thing: its curiosity. Now, the Chinese are considering joining the list of people with a desire to explore the Earth's evil twin, Venus. The mission. According to information from a July 9th conference to discuss the mission, the proposed mission, known as the Venus Volcano Imaging and Climate Explorer, would launch in 2026 and reach orbit around the solar system's hottest and brightest planet in 2027. The spacecraft would study the geological evolution of Venus, the thermal and chemical processes that occur in the planet's atmosphere, the interactions between the surface and the atmosphere, and the possibility of a habitable environment and life in the Venusian clouds using a circular polar orbit at an altitude of 220 miles. An S-band polarimetric synthetic aperture radar that could map the surface of Venus through the planet's clouds, and a multispectral imager that could monitor Venus in the ultraviolet, visible, and near-infrared would be among the scientific instruments. The Tianwen-1 Mars mission is currently underway, and the Tianwen-2 near-Earth asteroid and Mars sample return missions are planned. VOICE is a candidate mission for a space science program that is somewhat distinct from China's main lunar and planetary exploration missions, which are led by the China National Space Administration. As part of the third strategic priority program on space science, which the Chinese Academy of Sciences is overseeing, the proposed mission is instead being evaluated as one of the 13 candidate missions. The VOICE mission appears to be competing with 3 others in the category of planetary and Earth science: the E-type asteroid sample return mission to collect samples from the asteroid 1989 ML and deliver them to Earth, the low Earth orbit climate and atmospheric components exploring satellites mission, and the ocean surface current multi-scale observation mission. Although it is unclear how many missions will be permitted, the potential candidates will soon be assessed based on the available funding, the state of technology, and the production timeline. Other ideas from astronomy and astrophysics, planetary studies, and heliophysics. 4 spacecraft, including a satellite for quantum science and a probe for the search for dark matter, were launched as part of China's SPP missions in the first phase. The Einstein probe, which will launch in 2023 to study extreme physics, and the Solar Wind Magnetosphere Lonosphere Link Explorer, a partnership with the European Space Agency to study interactions between the Sun and Earth, are 2 missions that will be part of the second SPP round. The third series of missions would probably launch between 2026 and the end of the decade. Other Venus projects. If chosen, VOICE would join the ESA's Envision spacecraft and 2 NASA missions to Venus. Additionally, India tends to launch the Shukriyan orbiter a year after California's Rocket Lab launches a private Venus mission. Additionally, Russia has made plans for the Venera D mission, which will take off in 2029. However, Russia's invasion of Ukraine put a halt to any NASA participation in the program. China's planetary missions. In 2020, the nation launched Tianwen-1, its first interplanetary mission to Mars. The mission's orbiter and Zhurong rover are still active on the Red Planet. However, the mission won't be undertaken in isolation as China has additional travel plans. Tianwen-2, 3, and 4 missions are planned to come after the Mars expedition, according to Wu Weiren, the head designer of China's lunar exploration program, who announced last month to Chinese official media. A trip to Venus was, nevertheless, suggested by Chinese scientists at the beginning of the previous decade. According to a 2014 report, the orbiter mission, which was not chosen for further development work, would have focused on the planet's atmosphere, ionosphere, and magnetosphere, and conducted surveys of its surface and interior structure. Why explore Venus? Following the September 2020 news of the discovery of phosphine, a molecule linked to life processes on Earth in the Venusian atmosphere, the second planet from the Sun became a hot issue. The chemical signature of phosphine, which experts believe may be connected to life, has been found in the clouds of the second rock from the Sun, according to a team of astronomers. Even while there is no certainty that life exists on Venus, astronomers say the discovery highlights the necessity for future trips to the hot, gaseous planet next door. Some scientists, however, weren't persuaded that phosphine was a trustworthy indicator of living things. On Earth, the one phosphorus molecule surrounded by 3 hydrogen molecules is rare and short-lived. Industrial processes can make it, and even some bacterium species that survive in unusual circumstances are known to produce it. Moreover, it swiftly changes in the oxygen-rich atmosphere of Earth and should do the same on Venus, which is exciting to researchers hunting for extraterrestrial breath. However, the hype around phosphine might be overblown. The phosphine link to the biological world is very, very faint and needs to be corroborated, simply by going to the lab and doing experiments, according to Tetjana Milojevic, a biochemist at the University of Vienna. Another catastrophic fault in the concept of phosphine as a biosignature may exist. After Earth, 2 gas giants, and Venus, phosphine has now been found on 4 planets. According to the latest discovery, Venus has phosphine levels comparable to those of Jupiter and Saturn. But according to Pasic, this is 1,000 times more prevalent than on Earth. The gas giants have been proven to be incapable of supporting life, so what's the guarantee that Venus can? Some investigations have already been carried out for decades with slightly encouraging outcomes. The last Venus mission. The 24-hour near-polar elliptical orbit of ESA's last mission, Venus Express, allowed the investigation of Venus's atmosphere, plasma environment, and surface features. A Soyuz FG Fregat combo operated by Starsem, a French business that sells a European variant of the Russian Soyuz, was used to send the spacecraft into orbit. 96 minutes after launch, the Fregat fired again to send the entire stack out of the Earth orbit and toward Venus. The Soyuz FG had previously delivered the payload into a low Earth orbit. On April 11, 2006, the spacecraft reached Venus after a 5-month voyage. Venus Express became the first European spacecraft to orbit Venus when its main engine burned at 7:10:29 UT to place the spacecraft into orbit around the planet. By May 7, 2007, it had reached its operational orbit around 155, 41,000 miles in diameter. It was intended for the Venus Express mission to last no longer than 500 Earth days, but 5 extensions were made to May 2009, December 2009, December 2012, 2014, and eventually 2015. One of the spacecraft's first successes was to create an exhaustive temperature map of Venus's southern hemisphere by December 2006. Other significant discoveries included proof of ancient oceans on Venus's surface, a higher incandescence of lighting on Venus than on Earth, and the discovery of a massive double air vortex at the planet's south pole. Researchers using data from Venus Express in 2011 announced the discovery of an ozone layer in the upper atmosphere. Routine scientific studies were completed on May 15, 2014, after 8 years in orbit, as the propellant supplies to maintain its elliptical orbit started to run low. The mission scientists made the decision to perform a series of aerobraking procedures that would cause the spacecraft to descend further into the atmosphere than it had previously. These dips lasted for approximately 100 seconds, with a maximum dynamic pressure that was likely a record for a spacecraft that was still orbiting a planet. The spacecraft began a 15-day climb beginning on July 12, 2014, following almost a month of surfing in and out of the atmosphere, during which crucial data was gathered on atmospheric drag and heating effects. The last ascent resulted in an orbit with the lowest point of approximately 285 miles. The orbit of the Venus Express continued to decline naturally for the rest of the year after reaching this point. There was an attempt to stop the decay in late November, but on November 28, 2014, contact with the spacecraft was lost, and there were only sporadic telemetry and telecommand contacts after that. Even though a carrier signal was still being received, ESA officially announced that the mission was over on December 16, 2014. This X-band carrier signal was last picked up on January 19, 2015, which indicates that the orbiter burned up in the atmosphere shortly after. Venus seems to be a hotspot for activity in the coming years. Do you think the explorations are worth the cost? Let us know in the comments below.